Hey guys, just trying to blow this beach ball up. We're getting ready to go to the beach and fly a kite, and I thought this beach ball would be a great addition, so hang on one second. Well, I might have to save this for later. Whew. Excuse me. Like I said today, guys, thinking about going to the beach. We're going to talk about kites today because we're going to have a little kite flying contest in our class. And so I want to learn a little bit about kites so that we'll be able to fly them a little bit better and understand them a little bit better when the time comes. Okay? So let's talk about trapezoids and kites. Okay. In this lesson, you're going to learn to use the properties. Alright, welcome to 6.6, Properties of Trapezoids and Kites. In this lesson, we're going to learn to use the properties of kites to solve problems, and we're also going to learn how to use the properties of trapezoids to solve problems. Okay, let's talk about a kite first. A kite is a quadrilateral because it has four sides with exactly two pairs of consecutive congruent sides. Okay, so exactly two pairs of consecutive congruent sides. Okay, so we would call this kite A, B, C, D. Okay, we've got a couple of properties of kites that we're going to go through. And in theorem 6.6.1, if a quadrilateral is a kite, then its diagonals are perpendicular. And so when we see a diagram like this, and we know that this is a kite because it has two pairs, one pair here, of consecutive congruent angles, we can say that AC is perpendicular to DB. That's a conclusion that we can make. And so I can go ahead and mark this 90-degree angle here. Okay, that's going to be a property that we'll use. In 6.6.2, if a quadrilateral is a kite, we know it's a kite because it has two sets of congruent consecutive sides, then it has exactly one pair of opposite angles that are congruent. So we could say that angle D is congruent to angle B. But what that implies also for us is that angle A is not congruent to angle C. So if one of the sets is congruent, the other set can't be congruent. Okay, so those are the two properties of kites that we're going to use so far to kind of work with our kite problems. Okay, example one is going to be a problem-solving application. We're going to look at that one in class. So go ahead and pause here and draw this picture of this kite. We're going to talk about this one in class. I'm going to move on to example 2. And in example 2, we have three things that we're going to find. All three of them are angle measures. The first one that we're going to find is the measure of angle GFJ. In this kite EFGH here, we have that the measure of angle FEJ, so FEJ is 25 degrees, and the measure of FGJ is 57 degrees. Okay, so here's what we know so far. If we have a kite, we can go ahead and mark these angles congruent. So I know that this angle here is congruent to this angle here. So GFE is congruent to GHE. That's what I know so far. So let's use the properties that they've talked about in the example, in the problem, to find what we want. I'm looking for GFJ. Well, I also know that this is a 90-degree angle here, right? Because the diagonals of a kite are perpendicular. And so I have a triangle here that has 90 degrees, 57 degrees, and some other angle that I don't know, I'll call it X, is equal to 180. Well, when I go ahead and solve for this, I have 147 plus X is equal to 180. So I subtract 147 from both sides, and I get X is equal to 33. And so this angle here is going to be 33 degrees. Okay? Go ahead and write it in. I also want to find JFE, so I'm going to find the other half of this angle. Well, once again, I have this 90-degree angle here, and so I have 90 plus 25 plus angle that I don't know here, X, is equal to 180. So if I solve this, 115 plus x is equal to 180, then I end up with something that gives me x is equal to 65 degrees. And so I can mark this one as 65 degrees. Okay? And when they ask me in this last problem to find GHE, well, I know that this whole angle, the measure of GHE, is equal to the measure of angle GFE. Well, the measure of angle GFE is equal to 65 plus 33, which is 98. And so GHE must equal 98 degrees because a kite has exactly one pair of angles that are congruent and they're opposite of each other. Okay? And so that's how I can use the properties of kites to solve for these missing values. The next example is example 2.5. Save that one, try that one on your own, and we'll bring it to class. We're going to talk about it. Okay? So I'm going to scroll down and allow you some time to talk about this one on your own and to copy it down. Okay? So pause it here, copy this one down. Okay, so now we're going to talk about trapezoids. The general properties of trapezoids are fairly easy to understand if you've got a basic knowledge of what a trapezoid is. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay, so the one pair of parallel sides. And so this pair of parallel sides gives us a trapezoid. Okay, so BC is parallel to AD. BC and AD are called the bases. Okay, so the parallel sides are called bases. Okay, so this is a base and this is a base. Okay, now the other two sides and I'll call them non-parallel, are called legs. And so when I label these, this is a leg and this is a leg. So AB and CD are legs. There's one other piece we need to talk about here. If the legs are congruent, the trapezoid is called isosceles. Okay, so if the legs are congruent, the trapezoid is called isosceles. Okay, also, these are called base angles because they're the angles that are connected to the base. And these are called base angles. If we talk about base angles, and we talk about isosceles trapezoid, if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So, because this is an isosceles trapezoid, it has two congruent legs, then we can say angle B is congruent to angle C, and angle A is congruent to angle D. So isosceles trapezoid is just like an isosceles triangle. The legs are congruent, so the base angles must be congruent. Okay? If a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. So when we see something like this, where angle A is congruent to angle D, we could say ABCD is isosceles. Okay? The last part. A trapezoid is isosceles if and only if its diagonals are congruent. So, if AC is congruent to BD, we do the double-headed arrow because it's a biconditional. It's two conditions. So if AC is congruent to BD, then ABCD is isosceles. But if ABCD is isosceles, then the diagonals are congruent. It works both ways. Okay? So let's fulfill that second objective. Let's use the properties of isosceles trapezoids to find some measures and to solve some problems. We're going to find the measure of angle Y. It's important that in an isosceles triangle, an isosceles trapezoid, or if we're talking about any kind of trapezoid, we understand that two of the sides are parallel, which gives us a lot of things that we already know how to do. Because if they're parallel, then we have things like alternate interior angles, alternate exterior angles, we have same side interior angles, and consecutive angles. Well, we know that if these two lines are parallel, then the measure of angle X plus the measure of angle W is equal to 180. Well, what we'll do is we'll substitute because the measure of angle X we don't know, but we have 117 here. And so when we solve for this, we end up with something that will give us the measure of actually two angles that we want. Whoops. Let's do a redo on that. Okay, so the measure of angle X is equal to, and this is going to be 63 degrees. And so this is 63. We don't necessarily want X, but we know that because this is isosceles, that this angle X is congruent to angle Y, so the measure of angle X is congruent to the measure of angle Y. The measure of angle Y is 63 degrees. Okay, so we used another base angle to solve for the measure of that angle. Let's think about RT. We have a couple of pieces of information, and this is stuff that I'm giving you. So RT is 24.1. Okay, QP is equal to 9.6. We want to find PS. Okay? That's information that was given. So what I just wrote in was already given. You should write that down as stuff that's already there. Okay? So RT is going to be 24.1. So we know that RT is congruent to QS. Right? Because QS and RT are the diagonals of an isosceles trapezoid. So they are congruent. Well, this means for us that 24.1 is equal to QS. Well, QS is really equal to QP plus PS. Okay? Because QS is a segment, so we use the segment addition postulate. So 24.1 is equal to QP plus PS. Well, 24.1 is 9.6 plus PS. When we subtract 9.6 from both sides, we end up with PS equals 14.5. Okay, so that's how this works. We did those two. I would like for you to find the second two. Okay, now I'm going to write in some additional information here. We need to find the measure of angle F. Well, the measure of angle F we're going to find knowing that this is 49 degrees. And we're given information here that JN is 10.6, NL is 14.8. I want you to find KM. Okay, you try those two. We will talk about those two in class. Okay? Now, I'm going to move down. Here's another example. when we talk about this example, we have two base angles here that are congruent. And so what we are going to do is we are going to say this is an isosceles trapezoid. How do we know? Okay? Now, we know that this is an isosceles trapezoid because they just told us that this is an isosceles trapezoid. So we know that base angles are congruent. Okay? So we're going to set these two equal to one another. So 2y squared minus 25 is equal to y squared plus 24. Okay? Base angles are congruent. So I'm going to add 25 here. I have 2y squared is equal to y squared plus 49. I'll subtract y squared. I have y squared is equal to 49. So y is 7 or negative 7. Okay? So that's how this works. I would like for you to try the next one. Okay? I want you to try this next one. We will talk about it in class. Okay? I will give you a hint. You're going to use the properties of the diagonals of a trapezoid to find the answer to this problem. Okay? Alright, let's talk about our last piece. The mid-segment of a trapezoid is the segment whose endpoints are the midpoints of the legs of the trapezoid. So notice, XY is the mid-segment. I will label it mid-segment. Okay? That's the mid-segment. And our theorem says this. Our theorem says the mid-segment is 1. Parallel to the two bases. So our mid-segment is parallel to the two bases. It is also 1/2 the length of the sum of the bases. So AD plus BC over 2 is equal to XY. So we add the two bases, divide by 2 to get the mid-segment. Let's solve one problem with this. We want to find ST. Okay? So ST we're going to label with an X because we don't know it. But we know that the mid-segment, MN, we know it's the mid-segment because it directly divides each of the legs in half. MN is equal to 1/2 the sum of the bases, X plus 38. Or we could rewrite this as MN is equal to X plus 38 over 2. So we can substitute here. MN is 31 is equal to X plus 38 over 2. I will multiply by 2 on both sides. 62 is equal to X plus 38. I subtract 38. I subtract 38. And I end up with X is equal to 24, which means ST is equal to 24. We've used the properties of trapezoids and kites to find various examples of how we can figure out different lengths in these shapes. I hope you guys learned a little bit. Make sure you bring those examples to class, and we'll see you next time. Thanks, guys.